Hello, today we're going to be talking about writing equations of lines. And the lines that we are most familiar with, or the equation that we're most familiar with, is slope-intercept form, which is y equals mx plus b, where m is our slope and b is our y-intercept. Now, for it to be a y-intercept, that means that's the point that it crosses the y-axis. So this point really looks like 0, b, where the x value is 0 and the y value is b. And m is our slope. Okay, recall that the slope is the change in the y, your change in y divided by change in x. And that tells us, we know, we've heard of that as rise over run, and we know the formula to that for that to be y2 minus y1 over x2 minus x1. And I have suggested that you use the stack and subtract method in order to make sure that your numbers are in the correct order. Okay, so if we have a slope-intercept form of a line, and we're given an equation that is not in slope-intercept form, can you convert it? Okay, so that would be the step one. So if we have 2x plus 3y equals 8, and I want you to write this in slope-intercept form, the first step would be to isolate your variable term. So we're solving this equation for y. Okay, so if we're going to isolate this variable term, we need to move 2x to the other side of the equation. So we do that by subtracting 2x from each side. Now we can't take 2x from 8 simply because they're not like terms. So when we rewrite this, we've got 3y equals negative 2x plus 8. You could also have said 3y equals 8 minus 2x, but I want this in slope-intercept form, mx plus b, which means I really want my x term first. Okay, so I'm not quite done yet, because in order for it to be in slope-intercept form, I actually need y completely by itself. So I'm going to do that by dividing both sides of my equation by 3. So I have y equals negative 2/3 x plus 8/3. So this equation here is in standard form, and I have now rewritten it to slope-intercept form. Okay, let's try one more of these. What if we had the equation that said 2, I can't get 2 out of my head, so 2x minus 16y equals 3. Okay, again, we're solving this. We want to write this in slope-intercept form. So our first step is going to be to subtract 2x from each side. And when we do that, we're left with negative 16y equals negative 2x plus 3, because they cancel out on the left side. And then we're going to divide everything by negative 16. So when I do that, I'm left with y equals 2/16 x minus 3/16, because I simply said this is a negative 3/16. So I just simplified it by putting the minus here. Okay, so now our problem is we've got a fraction in here that needs to be simplified. So the solution is not completely done until you have reduced your fraction. So 2/16 can be reduced to 1/8 minus, so I have y equals 1/8 x minus 3/16. And that would be my final answer. Okay, so most equations we want to be written in slope-intercept form just because it's easy to graph and it's easy for us to compare the slopes and the y-intercepts. And that's important when we're talking about parallel and perpendicular lines, mostly parallel lines. So, point-slope form of a line. Point-slope form of a line is a form that you may not have too much familiarity with, but it's a really powerful form, and that's because we can use this to write equations. So if you're given 2 points, say we're given the points of, let's find 2 points. We're given 2 points. It doesn't matter what they are. Let's use the points 2, 6 and the point -3, 4. And we want to use the point-slope form of a line. Well, we've got m, which means slope. And hopefully you remember that x1, y1 would mean an ordered pair. x1, y1 is simply an ordered pair, and that would be the first ordered pair. Now, it doesn't matter which point that we choose to use as x1, y1, but again, you have to use values like that correspond. So we would use either 2 as our x1 and 6 as our y1, or we would use -3 as our x1 and 4 as our y1. But you're not allowed to intermingle these 2 points. So our first step is we need a slope. And you know how to come up with a slope between these 2 ordered pairs of 2, 6 and -3, 4. So we need to do that. Again, my suggestion is to stack and subtract. It's not like law or anything, but that would be my strong suggestion. So when I do that, I have 6 minus 4 divided by 2 minus a -3. Okay, again, it's because we have our change in y over our change in x. So what does this equal? Well, I'm writing in blue, so I'm doing that first. 2 minus a negative is going to be a big old positive, so 2 plus 3 is 5, and 6 minus 4 is 2, so my slope is going to be 2/5. So this is what I'm going to be substituting in for my m. Okay, so I like to rewrite my equations, and I suggest you rewrite your equations before you start substituting things in so you know exactly what equation you're using, and it tells you where to put everything. Okay, so I know this is my slope. So this is going to get put in here where the m is. This is my 2/5. Okay, this is my x and this is my y. Now, we're going to use, let's pick an ordered pair, and we're going to pick some colors to choose. I've already chosen, let's do a nice little purple. We're going to let our x1 be 2. So we're going to let our x1 be 2. And we're going to let our y1 be this fuchsia pink. Okay. So where I have my x1, I need to substitute a 2. And where I have my y1, I need to substitute that number 6. So my equation right now is y minus 6 equals 2/5 times x minus 2. And again, it's just because this is what I found. I found my slope is 2/5, so that goes in here for slope. My x1 is 2, so there's a 2. My y1 is 6, so I put a 6 in here. I leave my x and my y that don't have the little subnumbers alone. Okay, now I need to get this in slope-intercept form. Now I want it in slope-intercept form, again, so it's easy to look at what my slopes are. So when I compare, and I'm talking about parallel lines, everything is just in the exact same form. So I do that by distributing. I have to first start by distributing. So I'm distributing 2/5 to x and 2/5 to 2. So I have 2/5 x minus 2/5 times 2, and this equals y minus 6. Now I'm just going to simplify. Y minus 6 equals 2/5 x minus 4/5. Okay, now I'm not quite done because I have y minus 6 equals this, and I need y equals. So what do? Well, I have to get y by itself, and I do that by adding 6 to each side. So I have y equals 2/5 x minus 4/5 plus, and I need this 6 because I'm adding it to the 4/5, or to the negative 4/5, written as a fraction with a common denominator of probably 5, right? So I'm going to rewrite 6 as 30 over 5. Okay, And now I have negative 4 plus 30 is positive 26. So I have my final equation is y equals 2/5 x plus 26 fifths. And hopefully I didn't do anything wrong. I'm looking. It's looking pretty good. Okay, so that is how you use the point slope form of a line. If you're given 2 points, you first find the slope, and then you substitute it into your equation and choose one of the 2 points to use as x1, y1, and then go ahead and solve. Now, it shouldn't matter which equation or which point you choose. You should still end up with the exact same equation. Okay, let's try another one if we have time. Let's try to make this a fast one. Okay, what if I say I would like you to write an equation of a line that is parallel. So remember parallel. So parallel to y equals 1/2 x plus 4 that goes through the point 2, 6. Okay, so where do you start? Well, remember that equation, y minus y1 equals m times x minus x1. I'm asking you to find a line that's parallel to this given line. So what do I know about parallel lines? Well, hopefully I know that they have the same slope. So I have to first identify what my slope is of the line. And this is in slope-intercept form, so I have y equals mx plus b. So my slope is 1/2. So slope is equal to 1/2. So I'm going to substitute that in here for the 1/2. I've got this ordered pair over here, 2, 6. So I have that this is my x1. And I have, so I'm going to substitute the 2 in for x1, so that's going to go there. I've got that my 6 is my y1, so I'm going to put that here. And now I'm simply going to distribute. So if I distribute, I have y minus 6 equals 1/2 times x minus, because I'm distributing it across, 1/2 times 2. Okay, so y minus 6 equals 1/2 x minus 1. I then have to add 6 to each side, so I have y equals 1/2 x plus 5. So my equation of a line that is parallel to 1/2 x plus 4 that goes through the ordered pair of 2, 6 is y equals 1/2 x plus 5. Now, what would you do if they were perpendicular? Hopefully, you remember that perpendicular lines have slopes that are opposite reciprocals. Have slopes that are opposite reciprocals. So if you're given the equation y equals 2/3 x minus 6, and you're asked to give me a line that's perpendicular to that through the ordered pair of 1, 8, you would let 1 be your x1, or 8 be your y1, and you would say, okay, my given slope is 2/3. The opposite of that is negative, and the reciprocal of 2/3 is 3/2. So my new slope would be this one. So I would write an equation using y minus y1 equals m times x minus x1 with a slope of negative 3/2, where my x1 is 8 and my x1 is 1 and my y1 is 8.